In section 3.4, we take a look at some of the things that can affect the width of a confidence interval. And while we're going through a couple examples from the exercises at the end of the chapter from section 3.4, we will also do a little bit of review from the stuff we did in 3.2 and 3.3. So the first example is number 7 from the section 3.4 exercises, and there was a survey conducted that asked people why they think the main reason is that students get an education beyond high school. And 53% of the people they sampled said the reason was to earn more money. So the first thing we're going to do is find a 2SD confidence interval for the proportion of U.S. adults who would choose that answer to earn more money. And note to self, this 53%, that is our statistic, p hat. Okay, even though the question didn't ask you to, it would be a good idea to figure out what are the observational units and what is the variable in this case. And so I would recommend that you pause the video and actually write down these answers for yourself and then come back and see how well you did. In this case, the observational units are the U.S. adults. And you could also say the 1,001 U.S. adults that were surveyed, and that would be equally correct. If your answer to the observational units was 1,001, that's actually not correct because that's the sample size. The observational units have to be a description of people or things that we recorded the data on. Okay, and then the variable is whether the person chose as their answer to the question to earn more money. So, note to self, we have different ways we could sort of describe this variable. We were not told in this question what the entire list of options was for people to choose from when they were asked this question in the survey. So we could say which option the person chose. But generally we want to have something that is binary, so this variable is categorical and binary. Basically, say there were 5 different options of the main reason why students get an education beyond high school. Rather than saying which option having 5 choices, we're just going to turn it into whether they chose to earn more money or they chose something else, and in that way we create something that's binary. Okay, so the fact that our variable is categorical means that our statistic will have symbol p hat, which we said earlier, and also it will be a good idea for us to make note of the parameter in this case, and so the symbol for that is pi. And I'm going to actually write this in orange and note that the proportion of all U.S. adults who would choose to earn more money as the answer to the question, that is our parameter pi. So rather than rewriting that whole phrase, I've just outlined it here. That whole part that's outlined in orange is the description of the parameter, and the symbol for that would be pi. Okay, also, this 1,001, as I mentioned a minute ago, is the sample size, and the symbol for that is n. And so our 2SD confidence interval, remember, has confidence level 95%, and when our variable is categorical, we find that interval by taking the statistic p hat plus or minus 2, that's why it's called a 2SD interval, times the square root of p hat times 1 minus p hat all over n. So I, again, strongly encourage you to pause the video and try to figure this out for yourself, plug in the numbers and do the calculation, and then come back and see how you did. In this case, we have 0.53 that we're going to plug in for p hat. And then we also have 1,001 that we're going to plug in for n. So I'm going to take this one step at a time. First, I'm going to calculate the part under the square root and take the square root of that, and you should get 0.0158. So again, really important that you practice this with your own technology and make sure you're coming up with the correct answers. And if you're not, let me know so we can figure out what the problem is. Then I'm going to go ahead and multiply that by 2, and you should get 0.0316. And then we're going to do the subtraction and the addition separately. So when we have this plus or minus thing, then we do each piece, the plus and the minus, one at a time. I always put the minus on the left and the plus on the right, so that my confidence interval comes out in the correct order. And I'm a little out of space here, but when you do the subtraction, you should get 0.4984. And when you do the addition, you should get 0.5616. And that is our 2SD 95% confidence interval. And you might also take a moment and try interpreting that. I will see if I can squeeze that in here. We are 95% confident that, and now I'm going to save myself a little space. That entire piece that's in orange brackets above, the proportion of all U.S. adults who would choose to earn more money as their answer, that parameter is between, and here I'm going to switch to percentages, and I'm going to round to 1 decimal place. So I'm going to say 49.8% and 56.2%. So when our variable is categorical, the values in that confidence interval are proportions, and when we interpret, we often convert them to percentages so that they're easier for other people to understand. Most people have a pretty good relationship with percentages. Now again, this interval is estimating what the value of pi, the parameter, might be. So we already know the value of the statistic p hat is 53%. That's based on a sample of 1,001 U.S. adults. What we want to know is what might be the percentage for all U.S. adults, and that is what we're estimating with this confidence interval.